Good morning, everybody. Happy Wednesday, June 17th. Second to last geometry class for this school year. Today, our goal is to be able to determine the volume of irregular, three-dimensional shapes and volumes with holes, and describe what three-dimensional shape is made after rotating a two-dimensional shape.
Well, that's a lot of information, Miss Murphy.
That is a lot of information. This information is just so useful in real life careers. I know, for example, on the ASVAB military test, I see questions like this all the time. So if any of you going into the military, this will be very helpful. Plumbing, just so many different ways this can be used.
Landscaping, construction, a lot of these things, absolutely. So take a look at all these different types of shapes. Really, I would say the hardest part about these problems to find the volume is being able to visualize it. Because right now we're just looking on a screen. I mean, I would usually say you're looking at your piece of paper. Some of you might be. So if you're just looking at this, it's kind of hard to just pick out what I have to do here. So the idea is you have to imagine what shapes you have here. So let's see.
Mrs. Talhami, you know what this looks like to me?
What does it look like?
Something that has been very scarce during this pandemic.
Toilet paper?
This looks like a toilet paper roll to me with the hole in the center for the tube.
Absolutely, and I think you're right about that one. So here are the two shapes that you see here. They're both actually cylinders, so you have to imagine that this goes all the way through to the other side for both of them. So even on the inside one, you don't see it, but I'll draw it for you. Once I do this, sometimes it's a little bit easier. Oh, hey, look. This blue part on the outside looks like it's the toilet paper roll that Miss Murphy was talking about. And I got to get rid of that hole. So actually, it's no different than when we were doing area with holes, where you do the whole volume and you subtract from it any holes. So really, that's the goal here, being able to picture and visualize and do the math. And you have to use all the markings that they give you. So that's just this first example. I'm going to leave it up to you. I think you guys can handle the math, so I don't think we need to do the math for you. Here's another example with number 4. Look at this one. What shape are you almost primarily seeing here?
I'm visualizing a quarter of a whole circle.
And that's exactly what this is. We have a quarter of that circle. And how did you know it was a quarter, Miss Murphy? Because if I cut this into fourths, like Miss Murphy just said.
Right, I was seeing that as if you have 3 more of the same size pieces, it would make a whole circle.
Right, and then the other way you could tell yourself is, there's a 90-degree angle. You could also reduce 90 out of a full circle 360 to 1/4 as well. So it's 1/4 of a cylinder. So I think you guys can handle the math from there. I just want to really, really jump around and just see how much you can recognize. Here, there are 2 shapes here. If you visualize it, you'll see, hey, wait, there's half that cylinder.
It's like a dome archway.
Then,
or a greenhouse.
Yeah. And then here's the rectangular prism, and that follows all the way through. Notice, I see it go all the way through the shape. So it's very important that you can visualize this. That's the first part. If you need to take multiple colors to do this, you should, because then you'll be able to be like, hey, I could see those shapes, even though it's on a piece of paper or on a piece on the screen. I think I could figure it out. I hope you guys could figure out this Pac-Man looking thing, similar to number 4. Again, you're breaking up the shapes. Here you have 3 different shapes. I'm going to see if you could figure that out on your own. 3 different shapes. Okay? Number 9 is actually a very nice challenge. You're going to have to break it up. And then the only ones that I noticed as I was doing these that you can't figure out are numbers 10 and 12, because they did not give you enough information about the circle or the hole that's in this block. It almost looks like the blocks we use as we're growing up as kids. You ever have that block, Miss Murphy, where you have to fit the shapes in the right hole?
Yes.
Yeah.
Very important for children to do those kinds of activities.
So what I noticed here is this is a 4 by 4 by 4 cube, but they did not express the radius here. So number 10, I did as much work as I could, and then I got to the point where I couldn't finish the volume.
And you know what, Mrs. Talhami, on that one that you were just looking at, you know, this is again when you always told the students, don't assume. I mean, when I looked at this, it didn't look like a cube to me. It looked like a rectangular prism because it looks so much longer.
Right.
But again, use the information that's given. Look at those markings. It's telling us all of the measurements, length, width, and height are the same for. And so therefore, it is a cube.
Yep. And then you guys could do number 11. Again, you have to visualize the inner hole in order to be able to complete this. So watch what I'm about to do here. I'm going to actually paste it down here so that you can see this is what's inside of the shape. This is inside of it. You got to subtract this whole thing.
These are fun things to try to draw.
Absolutely. It's a lot easier with the iPad though, Miss Murphy.
It is.
And then here, number 12. So I noticed the big cylinder, and I want to subtract these two holes, these two cylinders. Problem is they did not give me any information about the radius. So I did as much as I could here, but then the final volumes for 12 and 10 were not doable. So I want you guys to do this. I want you to pause the video and try doing as many of these volumes that you can. And then I want you to come back and see all the colors and the that we use and labeling and all the answers that we have for you. But you do still have to come back because we still have to do the second part of our goal, which is describing a three-dimensional shape after it's rotating. So once we go through all of these, we're going to learn how to rotate a two-dimensional shape. Okay, great. So hopefully you guys completed the practice problems. So we're going to slowly just zoom in and let you take a look at each one of these problems.
Pause in between.
I want you guys to see the difference between numbers 2 and 3 in terms of what extra information they gave you. They said the inner radius is 2, so that means for the inner cylinder, the radius is 2. Here they gave you an inner diameter though, so if the diameter is 2, the inner radius is 1. So please make sure you see the difference there between those two pieces of information.
The whole minus the whole.
I hope you were able to pick up that the Pac-Man looking one was about 3/4 or 270 out of 360 because you take out the 90 degrees here. And some of you are just good enough to pick up that that's 3/4. Here I have to add half of a cylinder with a prism. Number 7 was pretty cool. We had a triangular prism, a rectangular prism, and half of a cylinder. So again, everything is color coordinated, so check out the work. These are always your exact answers. These are rounded to the nearest tenth. Just it's good practice to know how to do both. Half a cylinder. Here is...
Okay.
Go ahead, Miss Murphy.
No, I'm always thinking of real life applications to these diagrams. I went to Italy with Mrs. Gallion, and her her uncle owns a strawberry farm. And all you see are those types of domes in number 8.
Like this?
They're like greenhouses, yeah, that keep the plants protected with a clear plastic lining, but the sun shines through and it's irrigated from underneath, and he grows the most beautiful strawberries.
I can only imagine that they probably have to calculate the volume to figure out how much air they need to circulate in those greenhouses.
Yes, and how many greenhouses he can fit on the acreage that he owns.
Yeah, absolutely. Number 9. Number 9 was interesting because you actually had a half circle minus a half circle just to get this blue piece right here. So that's what the work you see here. That's why there's a minus. And then plus these two equivalent or congruent prisms right here. So this one was actually probably the one of the hardest ones to complete.
Looks like one of those huge magnets
Yeah, right?
that they use in machinery, or, to come down and
Pick up heavy stuff, yeah. Number 10, I already told you there was not enough info, but this is as much information as we can get. Here's number 11. And number 12. Again, not enough info, but it's really cool to try and draw those pieces to see what it's made of.
That looks like something I'd see in a car engine with, if you have a 6-cylinder or an 8-cylinder car engine.
Yeah. So that's how you find the volume of irregular shapes and a volume of shapes that have holes. So that's the first part of our goal for today. And then the second part is talking about 3-dimensional shapes after rotating a 2-dimensional shape. What does that mean? Now, what that means is, think about a revolving door. When you enter or exit some buildings, they have this revolving door here. The door is the shape of a rectangle, but if I spin that door round and round and round, if you guys ever seen the movie Elf and he starts running in circles and circles and circles, think about what 3-dimensional shape is made if he keeps spinning that door around some type of center. Okay, some of you might
Very cool.
Some of you might say, hey, that makes a cylinder. It's almost as if I attach a cardboard flag to my pencil and then I spin it really fast between my hands. You'll start seeing that cylinder. So that's kind of what this is doing right here. Number 1, I have a triangle attached to a pen or a pencil, and now I'm going to spin it really, really fast. So if I spin it really fast, what 3-dimensional shape will you see? Well, first you have to tell yourself, when it swings around to the other side, it's going to be like a reflection. So that's actually the first thing I like to do when trying to draw this, is I say, hey, it reflects over to the other side. Then I tell myself, but it's also spinning, so I have to imagine these circulars, distance that it's spinning. So this corner is going in a circular motion like that. And some of you might automatically see what 3-dimensional shape that is.
A cone.
So that's one way that you could rotate. And actually, for anyone who's interested in furthering their math skills, this actually comes up, I believe, in calculus. If one day you ever take calculus, they do rotate images about the x and y axis, and then you're going to have to find the volume. I mean, there's so much more math involved in calculus that you have not learned how to do yet, but you're going to have to try and find the volume of that shape. Because when we get to calculus, we start talking about 3 dimensions, not just x and y. We start saying x, y, and z.
Wow.
And number 2, again, I'm going to think it swings to the other side. Here's its reflection. And then I always like to go from corner to corner, and make myself that circular idea. What shape is this here?
A cylinder.
Let's try this one. So I'm going to do the reflection. And since there's no corners, I'm going to go from the edge and I'm going to make myself that circular piece.
Sphere.
You're doing a great job, Miss Murphy.
I have a good teacher.
No. This.
Ooh, now this one's a little different.
So
it's not connected to the pencil or the flagpole.
No. So here's its circle. So like I like to take the edges and say, this picture kind of makes me hungry.
Does it?
Yeah, you know why?
What does it look like to you?
It looks like a donut to me.
Ah.
Because you have this, that's what would, if I cut a donut, it's very hard to see. Very, very hard. But I'm going to write.
It's right, you're swinging this sphere. This kind of reminds me of one of my favorite games to play in summer. I don't know if you've had this in your yard, but it is a pole, and attached to it is a string from the top, and it's connected to either a soccer ball or a tennis ball.
Oh, and you like punch it and it spins around
Yeah,
the pole and it
spins
gets
around.
smaller. Yep.
Great exercise, lots of fun.
Yeah.
So that whole center part is empty, and it's just the ball, really, that if you can imagine it was dragging paint around with it, what it would look like.
Yeah, right? It's almost, I was thinking you were talking about that like skip, what's that skip that you attach to your foot?
Oh, to your ankle, and you spin it around, and you have to jump over it?
Yeah.
Lots of fun games.
Yeah, absolutely.
Good childhood memories.
Can you tell we're bored of being quarantined?
Again, this is not attached, so that you'll have a space in the center.
It's not too
and it's still going to rotate all around that pole.
So this one's actually like that toilet paper.
There's a lot of visualization. Looks like that toilet paper tube called a cylinder. Very, very cool.
That's not hole.
Cylinder with hole.
Yeah, yep. It just changed my E to an O.
Because you were thinking of a hole. Yes, hopefully none of you have run out of toilet paper during this quarantine. Mm-hmm. Although now they've, because of the need, have made so many new inventions.
Absolutely.
Spray hookups and all kinds of things. Number 6. Oh, now you're really going to get hungry. I see donuts everywhere.
Yeah, this one's like a sphere.
Yeah, with a hole.
It's a hole, but like it's like with an empty core.
Space. Yeah, an empty core.
It's pretty cool. It's very hard to draw 3-dimensional shapes on a 2-dimensional object, like a piece of paper or an iPad.
You must have had to practice this a lot.
A lot.
Over the years to get that down.
Absolutely. And then the last thing in number 7, they're telling you this is the 3-dimensional shape made. It's saying, but there's a cone subtracted from its volume. So if I subtract this cone, I have to imagine what shape would I rotate around this. So your first step is to cut this in half because you don't want to use the whole entire shape. You want to imagine that it's being reflected over. And
right, so you're going actually backwards from what you just did there.
Yeah. And then you have to really picture, hey, this is the shape that I have to rotate around this to get this, this 3-dimensional piece right here. This is what it looks like. That's called a cross section because I'm cutting it out and seeing what cross section is made.
They do that a lot in medical procedures when they're taking cross sections of tissue, tumors, things like that out. They're little slivers of a larger piece.
And then this one looks like this is the shape right here. That's what the shape looks like. So that you get that dome-looking thing.
Yes.
Yeah. Okay, and there you have it. That is how you determine what 3-dimensional shape you have after rotating a 2-dimensional shape. So that's it. You guys have one more meet after this on Friday. So don't forget to go in and do your little puzzle piece and go in and complete your short castle learning assignment. And we'll see you guys on Friday on our very last meet.
Hope you're all well.
Bye,
Take
everybody.
care. Bye.